Hello, this video is for IXL Activity A1.B.7. That's going to be in the Algebra 1 section. It is titled Evaluate Variable Expressions Involving Rational Numbers, and its 3-character code is Mike 9 Alpha. Now, rational numbers, a little bit of a quick review here. Rational numbers are like decimal numbers because we're going to see a lot of decimals in here. So it might be wise to have a discussion about classification in numbers. And so I'm going to go ahead and create a number line here so that we can kind of take a look at that. And if you've not done it yet, there is an assignment on classifying numbers. So this is a little bit of review, or maybe even a sneak peek ahead. But all the numbers 1, 2, 3, 4, etc., going up to positive infinity, those are known as natural numbers, the ones you naturally learn first as a child. And then if we throw in 0 as well, then we get the whole numbers. And easy way to remember that is just add 0 to the natural numbers, and the 0 looks like, you guessed it, a whole. And then we have integers. Integers are all of the whole numbers, which is all the natural numbers as well, and then all of their opposites. So we're talking about everything that's on these hash marks in the number line going in both directions, both to negative infinity and positive infinity. Integers are the numbers that live in the gaps in between, such as negative 1.75, which will be right about here, right? So those are rational numbers. So kind of give you an idea there of why you're going to see so many decimal numbers in this activity. So evaluate means plug in what they tell you the value of the variable is and then actually solve to get an answer. So we're going to do just that. Now I'm going to rewrite everything because it's always good to rewrite a problem. And there's no sign here, so I know between the negative 1.1 and the variable b that this is supposed to be multiplication. And I don't have to write times the negative, like the negative 8.4. And the reason for this, that I don't want to do that, is that decimal, especially whenever I'm dealing with decimals, that multiplication sign, it might mess me up. And I don't want to do negative 1.1 x negative 8.4, 4 times, because I am dealing with algebra and there are variables, right? They use letters that represent values that can change to represent values that can change. And so that could become confusing as well. So I'm going to do something different, and I'm going to go ahead and do the negative 1.1, and I'm going to use parentheses in order to show that that's multiplication. Plus, whenever you're evaluating and you're substituting in values that are given for these variables, it's good to use parentheses because your subtraction signs don't get confused with negative signs, etc., and you can kind of deal with it and recognize what's what. Just my advice is rewrite it, and do so by using just rewrite the whole thing and put a parenthesis wherever the variable is, and then plug it in and do the math. So let's go ahead and plug that in and do the math. So negative 8.4. So this is a negative times a negative, so it is going to equal positive. That I know, but I still need to multiply 1.1 times 8.4. And I'll go ahead and do that over here on the side. And I'm multiplying, right? 1 times 1, or 1 times 4 is 4. 1 times 8 is 8. And again, 1 times 1 is 4, and 1 times 8 is 8. I could have put a place holding 0 in there. Now let's add these up. 4, 12, carry the 1, 9. And here I have one number after the decimal. And here I have one number after the decimal. So 1 plus 1 is 2. So I know that I need to move that decimal over 2 places. So it's 1, 2, and I end up with 9.24. Kind of a sloppy looking 4 there. 9.24. 9.24. Outstanding. All right. Next page. T equals 20. They want us to evaluate the expression 4.7 minus t. So I'm going to write 4.7 minus and then the parenthesis. And I'm just going to fill it in. And it says it's 20. So I need to know 4.7 minus 20. Now, this is a positive minus a positive number. However, I kind of like the idea of 4. And I'm really getting ahead of myself there. 4.7, and I'm going to change the subtraction to addition. You probably seen me do this before in other videos. And then I'm going to take the opposite of 20 and get negative 20. The reason that I do this is because I want to have where I have addition and one's positive, one's negative. Because I know if I do that, I can then just subtract them, find the difference between the two numbers. So let's do that, 20, and I'm going to kind of totally avoid the negative sign for now. I'm just going to do 20, and I'm going to put 20.0 because I have one decimal place on the 4.7, and whenever you subtract decimal numbers, you need to line up the decimals. And so I'm going to need to do some borrowing here. So I'll make that 10, and I'll make this 9, and I'm going to make that 1. What I did is I borrowed 1 from the 2 to make this 0 a 10. Then I had to borrow 1 from that to make this a 10. That's why that became a 9. So 10 minus 7 is 3. I'm going to keep my decimal lined up there. And 9 minus 4 is 5. And I still have this 1 here, so I end up with 15.3. Now the question is this 15.3 positive or is it negative? Well, if I look back and I kind of pretend that the subtraction sign is not here, kind of like pretend that's not there, well, the 20 would be greater than the 4.7. Well, the 20 has a negative sign, so that means that our answer needs a negative sign as well. If I were to say that technically, I would say that the absolute value of negative 20 is greater than the absolute value of positive 4.7. So since the one with the greater absolute value has a negative sign, my answer will also be negative. All right, so evaluate the expression for r equals 4 and s equals negative 2.8. So I have, this is r times s minus r. So let's write down something times something minus something. See, I'm using the parentheses to just kind of rewrite it. Haven't even filled it in yet. So r is 4. I have an r there and an r there. And s is negative 2.8. Negative 2.8. So I need to multiply these two. So 2.8 times 4 and 32. Carry the 3. 4 times 2 is 8 plus 3 is 11. And I have one decimal place, so I'm going to move the decimal place over 1. And so I end up with 11.2. But this is a positive times a negative, so that's a negative 11.2. And then I have minus 4. Well, I'm going to put plus negative 4. Change the sign, subtraction to addition, and then change the positive 4 to a negative 4. Reason this helps is because now I have two negative numbers that are being added together, so I know the answer is going to be negative. I'm already starting out with a negative 11.2, and I'm just getting even more negative. Just like if they were positive numbers, I had a positive 11.2, and I was adding 4, the number would just get even more positive. And that would be what, 15.2, right? So because I have no decimal after this here, like 4.0, so 2 plus 0 is 2, so I know I'm going to have a 0.2 there. And then the 11 plus 4 is going to be 15. So I have a negative 15.2. All right. Next one, I have 10.4 minus whatever s is, and s is 15. Well, this is one of those times I might want to go ahead and take that 10.4, change the subtraction to addition. The opposite of 15 is negative 15. And now I'm adding a negative and positive number together. So I know I can actually subtract instead. So I'm going to take 15, and I do 15.0 because there's one decimal after this, and I need to line my decimals up to subtract, right? So 10.4. Now let's subtract those. I need to borrow, make this a 10, and that's going to become a 4. 10 minus 4 is 6. Keep my decimals lined up. 4 minus 0 is 4, and 1 minus 0 is 1. Yes. 4.6. There we go. 1 minus 0 is 0, so I end up with just 4.6. And negative 15 has a greater absolute value than negative 10, or positive 10.4. So since the negative is with the one with the greatest absolute value, I'm going to go ahead and make the answer have the same sign. On the next one, I have f plus 4 over f, and here we have f is equal to 4. So some number plus 4 over 4. I'm going to go ahead and plug that in for now. And I end up with 4. So in the lesson that we did from the textbook, we talked about how fractions are like grouping. We have to do the denominator before the we have to do the numerator and the denominator before we do the division of the fraction itself. So think of this as a grouping. We have to first do the numerator, then we do the denominator, then we can go ahead and perform it. So this is 4 plus 4, and I get 8. And let's bring that 4 over. Now every fraction is a division problem. So 8 divided by 4 is 2, and they're both positive, so the answer is positive. So my answer is positive 2. On we go to the next one. Here I have a negative 20 over m times n, so something times something. So I'm going to put 2 parentheses here, and then I'm going to fill them in. So m is 5, and n is 4. All right, so I've got the negative 20. I'll just bring that over, nothing to do there. Then 5 times 4, they're both positive. 5 times 4 is 20, so I end up with negative 20 over 20. So 20 divided by 20 is 1. Any number over itself is equal to 1. But this is a negative divided by a positive. So since we're multiplying or dividing, and they're different signs, negative divided by a positive is going to be negative. So I end up with negative 1. On this one here, I have a negative 35, and then it needs to be multiplied times the quantity of whatever g plus 2.8 is. So I'm going to use a parenthesis to hold that value of g in there, plus 2.8. Okay, now I'm going to put in that value of g, which happens to be negative 3. So I need to deal with this little part right here first. Okay, so I'm going to go ahead and deal with that first. I'm going to do that over here to the side. Negative 3 plus 2.8. Now I am adding a negative and positive number, so I could actually subtract them. So let's take the 3, and again, I'm going to use 1 decimal place because I have to line up my decimals, and there is 1 decimal in the 2.8, and I need to subtract these. So I'm going to borrow 1 from the 3, so that's going to make a 2, and this will become 10. And 10 minus 8 is 2. Keep those decimals lined up. 2 minus 2 is 0. So I end up with nothing there. So that equals 0.2. And the negative 3 has a greater absolute value than the positive 2.8. So the 3 is negative. So the answer is going to be negative. So I end up with negative 35 times, I solve for the inside of here, negative 0.2. So now I need to multiply this together, and it's negative times negative, so it's going to be positive. But I need to take 35 and multiply it times, and I'm just going to, well, yeah, let's go ahead and just do the 0.2. We'll go ahead and do that way there. I'll leave the decimal in it for now. 2 times 5 is 10, carry the 1. 2 times 3 is 6, carry the 1, add the 1, 7, and I have 1 decimal here, so I'll move the decimal over 1 place, and I end up with 7 for my answer. Negative times negative, it's positive. Good. Here, wow, it's getting bigger, isn't it? Aren't it? I'm going to start substituting some number minus some number minus some number. All that over some number times some number plus some number. Now let's start filling all that in. So V is right here, is supposed to be V, that's 17 right here. W is negative 2. See that minus and negative? That's kind of show you why I like to use the parentheses. And then X is positive 5. And then W is negative 2. Goes right there. X is positive 5. And V is 17. All right, so I'm going to work the numerator first, and let's take this as 17, then change this to positive, take the opposite of negative 2 is positive 2, and then minus 5. Or let's do this, plus negative 5, right? Change the subtraction to addition, then take the opposite of the following number. So all that, and then 17 plus 2 is 19. Add to that a negative 5, which is just like 17 minus 5. So the difference between 19 and 5 is 14. And the 19 is positive. It has a greater absolute value than negative 5. So since 19 is positive, the answer is going to be positive. So I end up with 14 for the numerator. And then let's work that denominator. I end up with the Negative 2 times 5 is negative 10, and then plus 17. And so I have a positive number or negative number being added to a positive number. So let's actually subtract those. 17 minus 10 is going to give me 7. And the 17 has a greater absolute value than the negative 10. Since the 17 is positive, I'm going to go ahead and leave that positive as well. Now I have 14 divided by 7 because every fraction is a division problem. 14 divided by 7 is 2, and it's positive divided by positive, so the answer is positive. So my resulting answer is 2. Here I have a numerator and denominator situation again, so I need to go ahead and do those separately. So we're going to first do the numerator, and the numerator is g plus h. So this is g, and I'm going to use the, by now you're probably thinking, okay, it's 5 plus, and then, oh, negative 5, right? And so we could also look at that as, well, good, it's already, I think we're going to get lucky there. Yeah, we're adding a 5. These are opposites, so it's going to equal 0, right? Outstanding. I don't have to go any further, actually, because I know that 0 over anything is going to equal 0. So anytime you divide 0 by anything, the answer is going to be 0. So once I got 0 for the numerator, I know I'm good to go. I don't have to work the rest of the problem. That's probably why I put that one in for an example. D plus F. Oh, here's another one. D is 5 plus F, which is negative 5. Well, these are additive inverses. They're like opposites, and so it's just going to put us back to 0. So 0 over whatever 3 times df is. I don't even know what the denominator is. I don't have to worry about it because the numerator is 0, so I just know that it's going to equal 0 as well. And this one here, k minus m. Let's do that numerator first. Some number minus some number. And k is 2, and m is negative 6. So let's do the 2, change the sign, and then opposite of negative 6 is positive 6. And you see where 2 plus 6 is 8 is a little less confusing of 2 minus negative 6. That's why I like to do it this way. So I know the numerator is 8, so let's throw that right down here. Just put that numerator as 8. And then I have the denominator, which is some number squared plus some number times some number. This is the denominator I'm working on. So k is 2, and then k is 2 again, and m is negative 6. So let's go ahead, do the exponents first here. So 2 squared is 4, and then 2 times negative 6. Well, 2 times 6 is 12, and a positive times negative is negative. So now I'm adding a positive and a negative number together, so I actually can do the difference of those and do 12 minus 4. I know that's 8. And since the 12 has a greater absolute, negative 12 has a greater absolute value than positive 4, I'm going to use that negative sign that goes with the 12, and that's negative 8. That's my denominator. I'm not done yet. Right, I still got to work the division part out. So 8 divided by 8 is 1. Any number over itself is equal to 1. And it is a positive divided by a negative, so different signs for division. So it's going to be negative 1. Here I have, let's see, they're all positive. So this might work out pretty nice. I can do 6 plus 2 plus 4. Once you start getting the hang of it, if you want, you can kind of take these type shortcuts. So 6 minus 2 is going to be 4, and 4 minus 4 is 0. Right, so I have 0 over whatever RST is. Double check. 6 minus 2 minus 4. 6 minus 2 is 4. Minus 4 is 0. Indeed, whatever this bottom part is, that's going to be 0 because the numerator worked out to be 0. And this is the last one here. J is negative 14. I'm making sure that you can't have a denominator of 0. We call that undefined. So let's work out the numerator. Some number times some number minus 7 times some number minus some number. Just put in parentheses for those. I'm just going to plug this all in. We'll work out the denominator part. We already know the denominator is negative 14. So let's look. H is negative 1, and J is negative 14. and K is -6. Oh, they're all negatives, aren't they? And J is again -14. So let's look at the order operations. We know that we have multiplication here and multiplication here. So we know we have to do the multiplications first. So let's go ahead and do that. 1 times 14 is 14. Negative times negative is positive. Minus, and then 7 times -6 is going to be a -42. And then I got minus my 14, -14. I'm going to do some rewriting here. 14, let's change the subtraction to plus, to addition. The opposite of -42 is +42. Change again the subtraction sign to addition and take the opposite of the next number. That's +14. And then I need to add all this together. 14 plus 42 is 42, 52, 56, right? Then I need to bring down this +14. And 56 plus 14 is, well, 56, add 10. Here, the way I'm looking at this, give you my mental math there. 56, add 10, 66, add 4 more, 70. So I end up with 70. Divided by, and J is -14. Now I happen to know that both of these are divisible by 7, so this will simplify. And it does say to simplify your answer. So let's go ahead and do this. 70 divided by 7 and 14 divided by 7. So let's see what we come up with there. 70 divided by 7, oh, I guess I could write the 7s down, is 10. And -14 divided by 7 is going to be -2. And so I end up with 10 over -2. And now that I have that, I can see this even will simplify further. 10 divided by 2 is 5. And positive divided by negative is a negative. So I end up with -5. Wow. Whew. Done, right? So those are all my examples for IXL A1.B.7. Remember, evaluate means plug in the value of the given value of the variable that you find in the expression, and then actually solve for an answer. Good luck on your activity.